This is lesson 4. Okay, so we will, if you look at the top, it says in previous work, we discovered that root of a fraction is the same as the fraction of the roots. That's what that first part says. But in essence, it just says to divide radicals, you just divide the numerical coefficients, and then you divide the radicands, and then simplify. So I'll show you that on, let's do part C, because that's what that says. Let's do part B, because it's exactly what this says. So divide the numerical coefficients. What's 8 divided by 2? 4. And then what's 21 divided by 3? So it's just the cube root of 7. So that's pretty straightforward. Let's take a look at A. Could you just go 30 divided by 6 is 5, and so the answer is square root 5? Yeah, you can definitely do that. So, but let's take a look at what we can do to show that. Let's break up 30. Let's break up 30 into square root 6, square root 5. The bottom is still square root 6. Because we know we can split them with multiplication, right? And then you'll see that these cancel. And you're just left with root 5. So that's another way to look at it. I mean, the other option is just to go 30 divided by 6 inside the little house, and it's 5, so square root 5. So what happens if they don't divide perfectly? Like 15 and 10 don't divide to a whole number. So just leave it as a fraction. It's just like reducing a fraction. So what's 15/10 the same as? Well, divide by 5 and divide by 5, you get 3 over 2. And if you don't want to do that and you want to just use your calculator, just go ahead and go 15 divided by 10 math fraction on your Texas Instruments, and you'll get this 3/2. Now 48 and 6 does divide evenly. You get root 8. Now root 8 can be further simplified, right? So don't forget to do that. Always check for further simplification. And square root 8 is the same as square root 4, square root 2. You guys agree with that? And the square root 4 turns into a 2. So 3 times 2 is 6. Oh my gosh. You have 6 root 2 over 2. And then even further simplification, you can see the 6 divided by 2 is now 3. Now that's not the only way to do it. There's you could have left the numbers on the outside, wait till the end. So yeah. Here. Put another way on the board. So if you felt like that was too fast, watch the whiteboard. 15 square root 48 over 10 root 6. So I know that 48 has a factor of 6. So I'm just going to rewrite 48 as root 6 root 8, 10 root 6. Those cancel. Root 8 is the same as 2 root 2. Root 8, right? 4 times 2, 4 comes out as a 2. So all I did was change root 8 to 2 root 2. Now I go 15 times 2 is 30, divided by 10 is 3 root 2. So there's lots of ways to get into this. My way, your way might look a bit different, but you got to end up at the same thing. Question?
I have a question where we have a fraction, and we have a negative root. Will we just put it in the bottom? Like we have a negative cube. Will we put the negative cube like in the bottom, or will we slowly put it on?
For a fraction, and if there's negatives? Yeah. And for cube roots? So for cube roots, the negative can go inside or outside. And for fractions, like if the top is negative and the bottom is positive, or vice versa, as long as they're different, then the whole fraction is negative. Okay, so I'm going to put up a mistake on here. 4 divided by 12 is 3. Is that right? Okay, don't make that mistake, okay? The bigger number's in the bottom, right? The bigger number's in the bottom, so this should be 1/3. Why? They both divide by 4, right? So that becomes 1, that becomes 3, 1/3. That's just reducing fractions. My little guy is doing that right now. He's in grade 5. And then how can we split the root A, root B? I would just split them just to see it. And you got like that. And then you just write it a little bit nicer, so you don't have to put the 1 on top. And let's just center the 3, and there it's done. Just make it look cute. So reducing fractions for the coefficients, simplifying the radicals, canceling, lots of stuff you can do. The other thing you could have done is you could have just did this. A, B over A. Those A's cancel like that. That's the other way you could have did it. For the radical anyway. Down to the bottom. Okay, 4/3. Can you do anything with 4/3? Okay, and then 54. Does it divide by 8 perfectly? No. Goes to 56, right? Multiples of 8, 56. So what are we going to do here? Let's just simplify the 54, because inside 54 is 27. But that's a cube. No, 27. Yeah, that's a cube. Is there a square? Yeah, 9, right? 9 times 6 is 54. So let's change 54 to root 9, root 6. Everybody okay with that? Times tables, 9 times 6, 54. Now watch this this cancellation. This is going to be so sexy. Watch this. Boom, boom. Oh, that was nice. Everyone's okay with that cancellation? What's root 9? So 3 divided by 3 is 1, right? So that cancels. We already know what 8 is. We talked about it a second ago. What's root 8? Root 8 is 2 root 2, right? Because 8 is 4 and a 2. The 2 stays, the 4 becomes 2 on the outside. Right? And then what happens with these two coefficients now? What do you do with these? Whoa! Massive highlight. What do you do with that 4 and 2? 4 divided by 2 is 2 over 1. Do you need to write the 1? I could. Whatever. Cool on that? Questions so far? Should we keep going on that one, or are we done? Keep going. It's like the confused look. Keep going. Can't you divide 6 and 2? Good question. What do you guys think? Yeah? What's it going to be? 2 root 3? Final answer? Beautiful. Does 126 and 112 divide perfectly? No. You guys want to cheat a little bit? I know you guys like to cheat. Just do this in your calculator. 126 divided by 112 math fraction. Does a whole bunch of work for you. Everybody likes the little shortcuts in life sometimes, right? You got a lot on your plates as a young person. Here's a nice little shortcut for you. 126 divided by 112 math fraction, what do you get? Say that again, 9 over 8? So root 9 over root 8. What's root 9? 3. So 8 times 3, 24 over root 8. We already know what root 8 is. 2 root 2. 24 divided by 2 is 12 over root 2. Okay, let's do this one a little bit different. Let's actually do what the instructions say. Because I'm not doing what the instructions say. Simplify numerator, and then the denominator, and then divide. What did we do? We did the opposite, right? We divided, and then we simplified. Why don't we do this exact same question that we just did, how the question wants us to do it. Let me change color. Okay, any squares that divide 126? Probably 4 maybe. Does 4 work? No? What about 9? 9 worked? And you got 14? Okay, so just going to do this again by simplifying. We get root 9, root 14, right? And then what divides root 112? Does 4 work? 112. Does 4 work? Yeah. 112 divided by 4 is 28. Is there a square inside 28? Yeah. So I bet there's a better one. 112 divides 16. All right, so I got root 16, root 7. Let's simplify this some more. 8 times 3 root 14 over 4 root 7. Eight and 4 will just cancel for a 2, and 2 times 3 is 6, and you get square root 2. So now the question becomes, did I screw up, or are those two things the same? Are they? Check the decimals. 12 divided by root 2. And 6 root 2. Oh my gosh, they're the same. Okay, so here's the issue. What happens if you have an equivalent answer, but it looks different, right? And you check your neighbor, right? So always pump it into your calculator and check the irrational decimals here. See if it matches. We're going to see this on the next page. Yep, we are. In this course, and in math in general, for the most part, they don't like the radical in the bottom. So just make a note of that. I'll put it on there for you. I'll put a little note in red here. Prefer rational denominator. So the two expressions are equivalent, but we prefer the rational denominator. So we prefer the bottom one because there's a denominator of 1. We don't like this one here, apparently. To me, I don't care. But for this book and for your course and for your tests, we're going to prefer rational denominators. You guys know what I mean by rational? The decimals are terminating or repeating, like normal numbers, fractions, integers. Question?
I thought that when, like, you went to go into the thing with the square root or whatever, when you told us the number, I thought you multiplied it by whatever number was already outside of the square root.
Yeah, we did do that. Which part are you talking about, the blue or the black?
The blue.
The blue. So I changed, what is that, 126 to root 9, root 14. It's basically 9 times 14 is 126, right? The 9 came out as a 3, and then 3 times 8 is right here. That's your 3 times 8. But there was a 4 on the bottom, and there was an 8 up there, so I canceled those for a 2.
Oh, I forgot it.
Yeah, no worries. Okay, let's do letter C. Let's follow their directions again. Do you guys recognize 162? 81 times 2, right? And 128, it ends in 8, so it's probably divisible by 8, maybe. Check it. Say what? 81's a cube, isn't it? Good eyes. So which cube divides it?
Oh wait, no, that's for
64 times 3? 18 times 9? How come we don't have a general consensus? What happens, hold on. What happens if you're confused? There might be some people in here that are confused. If you're confused, just start with the first cube on your list. 120, nope, top one. 162 divides, what's the first cube? 8. 8 didn't work. I got a decimal when I divided it. 162 divided by 27. It worked. 27 times 6. What? 64 times 3 I think is too big. Oh, that's for the bottom? 64 times 2, right? Good. Okay. We got, what's the cube root 27 come out to? 3. And then cube root 6 stays. And how about the bottom? Cube root 64 comes out as a 4. And the 2 will stay. What's those coefficients look like? 30 over 80. So 3/8. And how does the radicals work? 6 divided by 2 is 3. So I'll use a highlighter to just show you this general separation between these rationals and these irrationals. We have to treat them as like partners, like the regular numbers go together and the radicals go together. Bottom one on the page. Let's read the instructions this time. Divide each term in the numerator by the denominator and simplify. So what does this expression mean here? It means I'm going to take this whole numerator is being divided by root 6. And think about division as you would think about multiplication. If I was multiplying this square root 6, what would you do? Would you FOIL it in, multiply onto each one? You would. But with division, you don't multiply, obviously, you divide. So each one of these has to be divided. Okay? So we have root 24 over root 6 plus root 48 over root 6 plus, minus root 108 over root 6. And then we can just do them one at a time. Because it's all radicals divided by radicals, I would just pump these into my calculator. 24 divided by 6 is root 4, which will become 2, yes. 48 divided by 6 is going to be root 8. And then I don't know this one. Help. 18. Perfect. Now we can simplify these guys. Like you said earlier, root 4 is 2. We know root 8 is 2 root 2. We talked about that. And then 18 is 9 times 2, right? A 9 times 2, the 9 will come out as a 3 and the 2 stays. Oh, we got some like terms here, right? 2 minus 3, negative 1, root 2. 2 minus root 2. Final answer. There's many ways. class example 2, they wanted you to simplify first. That's like lesson 1. Do that first and then divide. Example 1 is divide first and then simplify. I know. It was an exploration. You can do it one way and stick with it. Absolutely. Yep. So the only problem is if you did it my way with the root 2 in the bottom, you'd have to fix that later, which I'll show you on this next page. Okay, so do you remember this? Remember this? I got to here, I didn't like it, so then I did it again. So we're going to show how to fix this. So if you ever end up in this situation and you want to fix this, that's what this page will be. Okay? Rationalizing the denominator. Yeah. I don't know. Where? The only one term is negative, this one, the last one. All the other two are positive. So it should be positive, positive, and then negative. Should be positive, positive, negative. Yeah, do you have more question? You sure? I can always come over there after, during the work period. Okay, so rationalizing. That's right here. This is the process of eliminating the radical from the denominator. And then if it's a binomial, that's next lesson. So we'll talk about that next lesson tomorrow. So right now we're just going to be rationalizing monomials. And guess what? It's really easy. All you got to do is times it by 1. What? Times it by 1? That's weird. What happens when you times by 1? Stays the same, right? So we're just going to multiply by 1 in a very clever fashion. We're going to copy the denominator and write it on the top and the bottom. Do you agree that root 13 divided by root 13 is 1? They could cancel and it would just be 1, right? Do you agree? And then what happens when you multiply by 1? Do you change your original form? Right. So all we're doing here is just changing the way this looks without actually changing the actual value of the expression. And we learned that when you do, check out my board. When you do root x times root x, you get x. So what's root 13 times root 13 in the bottom there? So 13 in the bottom. And then in the top, you just have 1 times root 13, which is root 13. Now, you have, I'll highlight them for you just to compare. This one's rational. Where we started, it was irrational. All non-perfect roots are irrational. And then we'll just show you the denominators. Or we'll just show you the decimals. So 1 divided by square root 13. And then square root 13 divided by 13. Okay, everybody comfortable with that? These two have the exact same decimals, so they must be equivalent. Okay? Again, use the calculator to verify. You remember verify? Did I do my algebra correctly? Well, let's use the calculator and test it out. Okay, so for the next one, what do we multiply by? You multiply by 1, yeah. But how do you do it cleverly? Root 2 over root 2. So what do you get in the top? root 10, and in the bottom, 2. Not bad, right? It only gets challenging when you have binomials and you have to do some magic stuff. You say conjugates? Did you? Yeah, you're a clever boy. Okay, let's take a look at this one. Okay, this is actually kind of cool to talk about. So this is just a fraction of irrational numbers. So what happens in fractions when the top is positive and the bottom is negative? So those fraction rules again. It's no different than multiplication, right? Division and multiplication are the same. So, or same but different. So with multiplication, what happens when you do a positive times a negative? It's negative. You guys all know that. So all this is the same. It's positive divided by a negative. So the whole fraction is negative. Okay, so you don't have to worry about is the top negative, is the bottom negative. The whole thing is negative if the two are different. Okay, so now let's multiply by whatever we need it to be. What do we multiply by? Root 6 over root 6. So don't worry about the negative. On the top you get negative, and that negative can go, I said don't worry about the negative, then I started with it. So just do the fraction, root 12 over 6, and the whole fraction is negative. And part D here, timesing by root 3 over root 3. Oh. How come I'm the only one who spotted this? Is there a problem in C? Everyone look at C. Is there a problem? Why did I don't think I should move on yet. The 12, what about the 12? Oh, no. Simplify, thank you. 12 would become, what, 4 by 3? The 4 comes out as so 2 root 3 over 6. Now look at this. You still have some work to do, still more. 2 and 6 will make 1 and 1. So negative root 3 over 3. You guys okay with that? Yeah, it's like in hockey, if you're breaking out of your zone, you never throw it up the middle. Maybe in soccer it might be similar, like never play it to the middle if you're not sure. Just play it to the outside. Well, in math, one of the things you always remember is like, always check for more. Always check for more simplification at the end. Always check for more. Okay, let's look at this last one. What's in the top? Root 60 over 3. Now 60 is big. Let's check it. 60 is like what? Good. 60 would be 4 and 15, right? So the 4 comes out as a 2. And 2/3 you can't reduce. And there's no squares in 15. It's so little, hey? Can you guys see it? Carl can't. Do you need it? Just need it for a second, or what? I'll take a drink. All right. A little bit different, but the same. What do we multiply by? 3 root 7 over 3 root 7. Okay, let's take a look at the tops. What's going to happen? 7 and 3 go together, right? 21 root 7. Now on the bottom, what do you have? 3 and 3 for sure make 9, right? No. Yeah, root 7 just makes 7. That's this. Root x just makes x. So root 7 makes 7. 3 and 3 make 9. 7 and 9 make 63. 21 and 63 both divisible by 3, yeah? Divide by 3, you get 7. Divide by 3, you get 21. You can keep going. Divide by 7, you get 1, you get 3. So it's root 7 over 3. Holy smokes. Do you need to know some times tables in this class, right? This one looks weird, right? Why is this one weird? The whole thing is being square root. It's not like in A where just the bottom has a radical. So let's split it. Root 18 over root 5. Split it. Don't be afraid to try something. That's another rule in math, especially in problem solving. Don't be afraid to just try something. So in this case, split it. See what you can do with that. Okay, what do I times by? Root 5 over root 5. That's what you want to bring in that's new. That's this new thing that's coming in. You're multiplying by 1. You're not changing the original expression. And you're trying to clean up the bottom. That's basically all you're doing. 18 times 5. Oh, 90, thank you. That's root 90 all over 5. That's why we do that. It makes it so nice. Like root 5, it's just 5. Now 90 is 9 times 10. 9 and 10. The 9 will come out as a 3. So you have 3 root 10 over 5. Oh! Okay. This one, I feel like I could clean it up before I rationalize. Anybody else see that? Clean before rationalize. I would go 12 divided by 72 math fraction. One over 6. So 3 over root 6 like that. Because 12 over 72, they both divide by 12. Divide by 12, you get 1. Divide by 12, you get 6. Now I can just rationalize something a little way cleaner. Root 6, root 6. The bottom's 6, obviously. And the top will be 3 root 6. Do I stop there or can I clean? 3 and 6 as a fraction is the same as half. One more to go, and then you're free. All right, so class example 6, they want us to try the same question 2 different ways. I guess just to show Kauser that it doesn't matter what way you do it. Okay, so we can rationalize the denominator first, or we could divide and then see what happens. So let's rationalize first. So 3 root 18 minus root 12 over root 2. What are we bringing in there as a rational factor, rationalizing factor? Root 2 over root 2. The bottom is just 2. And now the top, don't forget to distribute. So the left guy would be 3 root 36 minus root 24. Okay, and then because I seen 2 students do this today and I saw it yesterday as well, I'm just going to do a little note on the side. Please just watch. I've been seeing this a few times. Okay, do not do that. Don't make root 36 root 6. That's not true. Right? What should it be? Just 6. 24, how's that one break down? 12's not a square. 8's not a square. 4, right? 4 with 6. 4 coming out as a 2. 6 will stay. All over 2. We get 18 minus 2 root 6 over 2. Is that decent? Or could I keep going further on that? You could go further, right? How could you go further on that? Good. You could go 18 over 2 minus 2 root 6 over 2. And you get 9 minus root 6. Sorry. Give you guys a couple seconds and we'll start the next question. Looks exactly the same. Wonder which one will be faster. Okay, so they want us just to divide first. So that means you take everything in the numerator and divide it by the denominator. And root 18 over root 2 is root 9. That's just 3 times 3, which is 9. That was pretty easy. And over on the right hand side you got 12 divided by 2 is root 6. Wow. Which one was easier? Oh, this was way easier. Way easier. Okay, so the homework will be almost identical to the class examples. So there's 4 pages of this business. So if you want to do like every second question, that's cool. You know, especially in 1, 2, and 3, if you just do the odds or something. Oh, there'd be less if you did the evens. Okay, so on this page, if you just want to do A, C, and E, that'd be cool. For those hardcores out there that are doing all of it, I would totally recommend that. Especially if you see yourself taking a calculus course. You think you want to be that person that wants to go to the U of A and be in a sciences program, you have to take a math. And your mental math has to be on point if you want to do that. There's 2 options you get to the U of A. There's calculus, this is in sciences, calculus or linear algebra. 2 courses, that's for math. Especially, like, if you're not a math major, you still have to take it. It's crazy, right? You know those systems of equations that we did in Math 10? Like when there's 2 equations and you have to use elimination and substitution? Well, it's that, but with like 7 equations. Well, if you want to go to the U of A, you got to take that course, so sorry, buddy. Okay, with 4 and 5, similar story. If you want to do ACE, that would be cool. I would do all of 121, all of 122, all of this, up to 14 anyway. And then the numerical responses, you know, maybe Monday night before your test. So you guys got about 10 minutes before the bell will ring.